In this video, I'm going to be describing Rolle's theorem. Rolle's theorem simply states that if I have two inputs and I plug them into a function, they must give me the same output. And if that's true, then we have a minimum or a maximum occurring between those 2 points. We could use this graph to visualize what I just said. So if I have a function here in between the interval a and b, if I plug some input in and I get some output, and then I plug a different input in and I get the same output or the same height on my function, there must have occurred a minimum or a maximum in between those 2 points. We could think of it application-wise. If I throw a ball up in the air, it has to come back down. So at some point in its flight, at a specific time, it reached a certain height as it was going up. And then at a different time, when it was coming back down, it must have reached the same height. You could also think of an object in motion. If something is starting at rest and then speeding up, getting to a maximum speed and then slowing back down and stopping, it must have reached the same speed at 2 different times, once when it was speeding up and again when it was slowing down. More specifically, though, Rolle's theorem states that a function has to be continuous on a closed interval and differentiable on an open interval. That would just be the definition of an existence of a derivative. And if 2 inputs give us the same output, that's what this notation is saying. If I plug in a and I evaluate my function, that output must be the same as if I evaluated some different number b, plugged it into my function, and got the same output. If that is all true, then there must exist an input in between a and b on the open interval between them, so not including the endpoints, such that we get a horizontal tangent line or we reach some sort of extrema, whether it's a maximum or a minimum. So we can set the derivative equal to 0. That would be that horizontal tangent line. So let's do some examples. Sometimes we're asked to satisfy Rolle's theorem. So we're going to do 2 different things. First, we're going to verify that 2 different inputs give us the same output. If that occurs, then we know we can find a minimum or maximum. So we're going to find the derivative of the function and then set the derivative equal to 0 so that we can solve for the point at which this extrema is occurring. So let's do an example. Here we're given the function x squared minus 6x plus 1, just a quadratic, on the interval between 0 and 6. So I'm going to test my endpoints in my interval. If I plug 0 into my function, I get 1. If I plug 6 into my function, I also get 1. So because I get the same output plugging in 2 different inputs, I know that Rolle's theorem must apply. There must be a minimum or maximum existing in between these 2 points, and we can solve for that point. So if I find the derivative of my function, 2x minus 6, and set it equal to 0, I can then solve the equation to find exactly where this min or max is happening. Rolle's theorem is another existence theorem, so it's not telling us whether or not it's a minimum or a maximum, just that something has to occur. There has to be some sort of extrema happening. So we can use this process to determine exactly which one of those it is. So by solving the derivative, I can see that something is happening at x equals 3. We could use our knowledge of a quadratic. We know this parabola opening up, so I must have a minimum value happening at this horizontal tangent line. So at x equals 3, I have a minimum, and we could plug that into our original function to find the value of that minimum. But not necessary in this example. We're just guaranteeing that Rolle's theorem applies, and then finding the point at which extrema is happening. Here's a more complicated equation or function. I'm going to let you pause the video and just go through these steps. But it is possible that we could do this with a more complicated function. For example, this function is going to require the product rule to find the derivative. But before we even do that, we want to make sure that Rolle's theorem applies, and that's pretty basic. We're just going to plug in some numbers from our interval. In this case, we're going to plug in the endpoints on our interval. So if I plug in -8, that should be a -8. I'm plugging in -8, I get 0. And if I plug in 0, I also get 0. And so we know that Rolle's theorem applies in this case. So we can find the derivative. It might help to rewrite the function first in this form without the radical, and then find the derivative using the product rule. And there are a lot of different ways to simplify and solve. This is just one way. But eventually we find our solution. The point at which some extrema is occurring happens at x equals negative 16/3. And we can look at a graph to verify. So if I plug this original function into a graphing utility, then we can analyze it. And we can see this is the graph of my original function. We do in fact have some extrema happening, a minimum happening at x equals negative 16/3. One more example, we can do this also with trig functions. Rolle's theorem describes extrema happening at least once, but it could happen more than once, and we'll see that in this example. So if I have the function cosine of our input 2x on the interval negative pi to pi, let's first make sure that Rolle's theorem applies. I'm going to plug in my endpoints into the original function. Evaluating cosine of 2 pi gives me 1, and evaluating cosine of negative 2 pi gives me the same answer, positive 1. So we know that we have an extrema occurring in between these 2 points. We don't know how many or what type, but we do know they are occurring. So let's find the derivative of the function and set it equal to solve, and we can find the points at which this extrema is occurring. So the derivative of negative 2, or the derivative is negative 2 times the sine of 2x. If we set it equal to 0, that's going to undo our negative 2, and we just want to solve this equation. To do that, we need to kind of think a little bit backwards. So I want to evaluate sine of something and set it equal to 0. If we just think about our unit circle, where does our sine function equal 0? Well, it occurs anywhere where our height is 0, so that would be on the x-axis. So it would occur at the angle measure 0, or pi, or 2 pi, or if we think about negative angles, it could also occur at negative pi, or negative 2 pi. But we got to check our domain. We're only talking about values in between negative pi and pi. So I know that the sine function will equal 0 if I have inputs on that domain at 0 or positive and negative pi. We don't care about 2 pi or even negative 2 pi. But that would be sine of x. Since we want sine of 2x, I know that my input 2x has to be 0 or positive and negative pi, so that when I evaluate it, I get 0. So I want to know 2x. How do I find 2x equals 0 or 2x equals positive or negative pi? So we can just solve those little equations. If I want 2x to equal 0, then x must equal 0. If I want my input 2x to equal positive or negative pi, well, my input has to be positive or negative pi over 2. Because then if I plug it in, that will cancel my 2, and I will get just positive or negative pi. And when I evaluate sine, I get 0. It's kind of a little convoluted way of thinking about it. We can then look at our graph and make sure that what we came up with actually occurred. So on our interval between negative pi and pi, we actually have 3 extrema occurring. So Rolle's theorem determines that it needs to happen at least once. It could happen more than that. So it actually occurs at negative pi over 2 here, at 0 here, and at positive pi over 2. So 3 points at which we have extrema occurring inside this interval from negative pi to pi. And so a lot of different places where 2 different inputs could give us the same output, there and there, or here and here, or here and here. So again, Rolle's theorem states that it needs to occur at least once, but it could occur more than that. So there's an introduction to Rolle's theorem. Make sure it's occurring, or that we're satisfying Rolle's theorem first, and then find the value at which extrema occur.